Let's look at this worksheet, 7.2. This worksheet has a combination of esters and carboxylic acids, and our job on this worksheet is to assign names to the esters and the carboxylic acids. So we're not coming up with the names ourselves, we're just going to be matching them up. The first thing that I want to do, though, is go through this worksheet and identify the carboxylic acids, just to give you some practice on what you're looking for when you're trying to find a carboxylic acid. So for carboxylic acids and esters and amides, all of them are based off of this carbon-oxygen double bond part of the functional group, and they're all going to have that piece in the molecule somewhere. So your first job is to find that carbon-oxygen double bond. And then you want to be focusing, once you find it, you want to be focusing on what is directly attached to the carbon-oxygen double bond. One thing that some students do is they look too far away. Like they'll start looking, oh, what's out here? What's out here? What's out here? That's not what you want to do. You want to just ignore all the rest of what's going on in the molecule, and you really just want to focus on what's directly attached to the carbon-oxygen double bond. And when you're looking at that carbon-oxygen double bond, what you're asking yourself, first thing that I'm asking myself is there an OH? Because if there's an OH, then that means that we have a carboxylic acid. And again, that OH has to be directly attached. It can't be anywhere else in the molecule. It has to be directly attached to the carbon-oxygen double bond right here. So let me just kind of modify this. If there was an OH out here hanging out like that, that would not make this molecule a carboxylic acid. It does not matter what's hanging out way out here at the end of the molecule. So let's get rid of all that again. We are going to go through and look for carboxylic acid. So we're starting by looking at the carbon-oxygen double bond and then asking ourselves, does this molecule have an OH hanging off of that carbon-oxygen double bond? And when I find one, I'm going to circle it. There's one, because we've got that OH right there. Here's another one. Here's another one. Here's another one. And one more. So there are our carboxylic acids on this worksheet. Now what I want to do is practice naming those carboxylic acids. And we do have some matching thing, like matching the names to the structures, but we're going to go through and just kind of walk through the rules of naming carboxylic acids to give some practice. So once we know that we're naming a carboxylic acid, we're going to find the longest parent chain and number it, starting with number 1 at the carboxylic acid group. That's always going to be carbon number 1. Once we get our carbon chain numbered, we're going to locate and name the substituents. This guy has a chloro on carbon number 2 and a methyl on carbon number 3. Remember that those are going to go in alphabetical order, so the chloro and the methyl are going to come first. And then we do not give the location of the carboxylic acid group as carbon number 1. We skip that completely, and we move on to the name of the parent chain. This is a 5-carbon chain, which is a pentane, but we are going to drop the E and replace it with oic acid, 2-chloro-3-methyl pentanoic acid, which looks like we have right here. So this is C, name C. Let's move on to our next one. This next one is a simpler molecule because it doesn't have any substituents. This is a 1, 2, 3, 4-carbon chain. A 4-carbon chain is butane, but drop the E, oic acid. Let's see if we can find butanoic acid. Butanoic acid. True story, butanoic acid smells like a mixture of diarrhea, vomit, and bad baby diapers. Next one. This is another simple one. This is a 1, 2-carbon carboxylic acid, so that's ethane, but drop the E, ethanoic acid. Let's see if we can find ethanoic acid. Oh, I see it. Ethanoic acid is E, Ethanoic acid has a common name, so like an everyday name, acetic acid. And you may have remember that from 121. Acetic acid is the acid that's present in vinegar. Here is our next carboxylic acid. This is a 1, 2, 3, 4, 5, 6 carbon chain. It has 3 substituents. They're all methyls, so that means we say trimethyl. Where are they located? They're on carbon 3, 4, and 5. 3, 4, 5 trimethyl hexanoic acid. 3, 4, 5 trimethyl hexanoic acid. There it is. Now this last one, let's pretend like this was a test and you weren't wanting to try to come up with the name on your own like I've been doing for the last few examples. Let's pretend like you were truly just trying to pick the right name off of the list. So if that were the case, how could you name this last one or find the right name of this last one? My advice to you would be to start by numbering the carbon chain and to see that you have a 2-bromo. And once I knew I have a 2-bromo, I would go straight up to the list and see what kind of 2-bromo options do I have in these names. And when I'm looking at all of these names, there's only one that has a 2-bromo in the name, so that it must be the right answer. So if this was a test, a multiple choice, choose the right name, I would just start by find the simplest way to look for something in the molecule's name that's going to match up with a possible answer.